Hello students, welcome to the session 3 of this new topic, number system. In the previous two topics we have discussed already how to present the rational numbers and irrational numbers between any two given number, how to find the decimal expressions of the rational and irrational numbers, and what is the natures. Now today we are going to learn about how to present these irrational numbers on the number line. So we have already discussed about the different forms of irrational numbers to be presented, and one of them is the real algebraic form, or it is called SOD form. Like we have learned already, the irrational numbers can be presented as root 2, root 3, such type of forms. So how to present those numbers on the number line, let us learn now. So today's topic is to learn about representation of irrational numbers on the number line. Okay, let us start how to represent an irrational number on the number line. I will select a number, let us take root 2. So how to represent root 2 on the number line, let me find. So representation of irrational numbers on number line. I have taken it here the example as root 2. So how I will do now? Let me take a line first. With the help of ruler I will take a line. I have selected a line. With that line, let me choose a point as O. Suppose this point I have chosen as O. At equal distances, let me take some points. Suppose this is my 1, and at the equal distance this is my 2, and this is my 3. Now if I'll select this point as 0, this is representing 1, this is 2, and this point is 3. So this is a number line. Now in this number line, I wanted to present this root 2 on this number line. Let me select a point 1, and then I will start from this point 1. I will draw a semicircle. Okay, with a semicircle, I will find the perpendicular on it. So this is a semicircle. Let me bisect this semicircle. And let me join this point to find this right angle. Okay, now I constructed a right angle at here. Now to find the same point, suppose this is my 0, and this 0 to 1 is 1 unit. Let me select this 1 unit at here, and on this line I will cut the same 1 unit. The same 1 unit let me cut at here. Now let me give the names as, suppose this is 0, this 0 point I will take as a O, this point I will select as A, and let me take this point as B. Now I will join this O and B. I will join this O and B. By joining this O and B, I find a right angle triangle AOB. OAB. And this in AOB, this OA, this distance is 1 unit. This AB distance is also 1 unit. This is also 1 unit. I have selected 1 unit, and this I have taken also 1 unit. Now this is 1 unit, this is 1 unit. By using Pythagoras theorem, we can know this the hypotenuse of this right angle triangle will be 1 square plus 1 square under root, and this equal to root 2 unit. Now this length represents root 2 unit if this length is considered as to be 1 unit. So now when it is be 1 unit, so how to bring this root 2 unit to the number line? To bring this root 2 unit to the number line, we have to again select our compass, select this point, this length, and bring it to here. So by this way, we got root 2, this length selected at here, and the arc got this number line at this point. So this point represents root 2. Now by this process we brought this root 2 in the number line. Okay. So now we understood how to present root 2 in the number line. Let me repeat again. So this is O, this is A, this is B. I have selected the length OA as 1 unit. At the point A, I drawn a perpendicular and taken this perpendicular length also 1 unit. Now from O to B I have joined. I created a triangle, right angle triangle OAB, whose hypotenuse I got as 1 square plus 1 square. It's under root. It is root 2 unit. Now this length I need to bring into the number line. So I selected this point O as the center, OB as the radius. Now keeping this center at fixed by my compass, I drawn an arc such that OB will be equal to this point. Now I can tell this point, let me call it as a B dash, because OB and OB dash, both of them are same length because the radius of the same circle. Now this length OB came into the number line. So from the point 0 to this point B dash, the length is root 2 unit. And this point B dash on the number line represent root 2. So this length I can say it's root 2 unit. This is root 2 unit. Okay. So now we learned how we have presented root 2 on the number line. Now if I want to find root 3 on the number line, similarly root 3 on the number line, so how I will do? Again from the same point, let me find the same point root 2 I already got on the number line. From that point, let me draw and again an perpendicular on it. So on this point, I can draw a perpendicular through my compass. I can bisect this 180 degree to find a perpendicular there. Now selecting those points, I can draw a perpendicular. Now this point and here I will join to find a right angle. Now this point is the perpendicular. Again, but I have to again choose this 1 unit length. How much is 1 unit from 0 to 1? That I will select again. Selecting that point, keeping on this root 2, I will cut a line. Now this point I have to join. When I join this point with 0, I will find is another triangle. Let me take this point as C. Now O, this point is B dash and it is C. So O B dash C is another triangle where this OB dash length is root 2 unit and it's a right angle triangle. I have taken this point, angle is right, so this unit is root 2 unit. This B dash C is 1 unit length I have taken. So the length of OC is now became, so it will be root 2 square plus 1 square and it's under root. So this will be 2 plus 1 that under root that equal to root 3. So now this OC length comes root 3 unit. And how to bring this root 3 unit to the number line? For that, I can take my compass. I will select this point O as center, OC as a radius, and I will draw an arc. Here I'll find the arc will cut this line at this point. Let me take this point as C dash. This point is C, so let me take this point as C dash. Now C dash is a point on the number line which represents root 3. Now by this process, I brought this root 3 also in the number line. So now we learned how to represent root 2, root 3, such type of irrational numbers on the number line. Similarly, in this process, we can also find by root 2, root 3 using this same number line, we can also create a square root spiral. That's a design we find in nature also. So let us see how this exists in the nature and how we can construct by using this process. Okay, let me draw it. I will to make it a new pattern. So let us select a line again. Let me select a line at here. This is my line. I have selected at here. So since I have to select it at a point 0 at here, let me take a point here, it is 1 unit. Here another point, it is 2 units suppose. Now with this 1 unit, let me find a perpendicular at 1. As I have seen, how do we have construct a perpendicular at there? So we can draw by using this. Now we can draw a perpendicular over there. Now this is the perpendicular we have constructed. Now as I have taken this 0 to 1 is 1 unit, I have to again select this 1 unit at here. Let me select 1 unit at here. Now this is my 1 unit. Let me join this point 0 to this point. Okay, so now what I did, I have constructed a line. Let me name this point. This point is, suppose it is 0. Let me take this point is O. This point is 1. Let me write it is A, and this point is B. So I have selected a line and I taken a point 0 at there, represented through this letter O. Now at 1 unit, I have taken another point, it is B. Now at 1, I have selected a perpendicular, I have constructed a perpendicular, and on the length of this perpendicular I taken is again 1 unit. Then I joined this point O to B. I constructed a triangle OAB. In this triangle, what I get, this right angle triangle, this OB length I got it is √2 unit. I have already seen this is 1 unit, this is 1 unit, so this length becomes now √2 unit. So let me write it is √2 unit. Now √2 unit is I have already taken. Now with this √2 unit, let me find one more right angle and I will draw another line. So at this point, let me extend this line a little more so that it will be easy for me to construct. So at this point, let me draw another right angle at here so that I can extend my line on this direction. Okay, so I will produce this line now to find the perpendicular on that point. So this is my √2 unit and I extended this unit. Again on that line I have to find one more 1 unit. I have selected already 1 unit at here. Let me choose 1 unit from here also. Again I have taken this and caught the arc. You will find this point represents, let us take C. Now this CB to C is 1 unit and this angle I have taken as right angle. Now this distance, this OB distance is √2 unit. Now this is √2 unit, this is 1 unit. If I join this O to C, what I will find? This length of OC represents now √3 unit. This represents now √3 unit. So in this process I got this is √3. If I will go on keeping this same process again, you will find at every point I will construct a perpendicular, I will extend this, and in the similar manner if I will draw, you will find, suppose let me find a right angle at here and I will take again the 1 unit there. With the same process, this 1 unit at there, I will cut. Then if I will join the next, I will find it is √4. This length is now √4. Now this length is, this is √3 unit, this is √1 unit, this is √3 unit, this is 1 unit. So √3 plus 1, √3 square plus 1, this angle is 90 degree I have taken. So this line becomes now, this length become now, this point is d, suppose it is become root 4. Root 4 means 2. 2 is a rational number, but we have presented through it the number, presentation is root 4. Now let us move to the next. In the same format, if we'll go on adding right angle set here in every point, I will find such type of numbers again in the same direction. And how the figures will create, let us see. Let us observe. If I'll select the same length 1 unit at every point, at there, I will find the next line is E. Joining E, I will find this point is E, suppose. So in this process, if I'll go on continuing, I will find there is a spiral. I will find there is a spiral. Okay, so that spiral is called as square root spiral. You can see the picture I have given, so not there, it's a square root spiral. By using this 1 unit, I got root 2, root 2 plus 1, I got this root 3, root 3 and 1, I got this root 4, root 4 again 1, I got root 5. If you keep on going like this, you will find there is a square root spiral. So such square root spiral I can see in nature also. You can see there is a nature also we will find the same type of square root spiral. You can see in the slide there is a picture given which is exactly looking like a square root spiral. If you go on adding many square root spirals, you will find that type of picture is very interesting. Okay, then we'll go to the next. On the number line, there are infinite smaller numbers lying between any two numbers. These smaller numbers can be of 2, 3 or more decimal places. To see or mark such numbers clearly, we use the process called successive magnification of the number line. Here, we use a virtual magnifying glass to enlarge the smaller divisions on the number line. This procedure can be used to visualize a real number with a non-terminating, non-recurring decimal expansions on the number line. Always the irrational numbers are not in this form of this real algebraic form. We can also find the numbers existing in decimal form. As in the last session we discussed, the irrational numbers we have presented through the non-repeating, non-terminating decimal numbers. For example, let me take an irrational number 5.377 and again 5 and so on. I have taken such a point 3775 and 7775 and so on. Okay, 5.3775, 775 and so on. So next will be 475 and so on it will be continuing. So such type of numbers are irrational numbers. So how to present such numbers in such irrational numbers on the number line? So for that we have to select a number line. Let us see how this can be presented in a number line. So let me find a number line at here. Okay. In this number line, let me take a point 5 at here. This point I have selected as 5, and this point I have selected as 5, and here I will select as a point 6. Okay, so I have selected a point 5 to 6. Then I divided it into 10 equal parts. Okay, so from this 10 equal parts, let me name them. It is 5.1. It is 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9 and it is 6.0. Now from this 10 equal parts, 5.37 lies within 5.3 and 5.4. So in that case, again I have to divide this 5.3 and 5.4 part into 10 equal parts. So through this successive magnification of the number line, I will draw another line to represent this 5.3 to 5.4 part extended. Okay. So here I have selected this point 5.3, and again at here I have selected a point 5.4. Between the same parts, again I divided into 10 equal parts. Now let me take it is 5.31. This point will be 5.32. This will be 5.33, 5.34, 5.35. Here it is 5.36, 5.37, 5.38, 5.39 and 5.40. Now again we have to find this 5.3775 lies within which numbers? Up to this point we have seen this 5.3 lies within 5 and 6. Then we came to 5.37 lies within 5.3 and 5.4. We extended this 5.3. We can see we have extended this 5.3 and this 5.4 part into 10 more equal parts. This 5.3 to 5.4 part we have extended into 10 equal parts. And from that point again we have find 5.37 lies within which? It lies within 5.37, between 5.37 and 5.38. Between those two numbers it lies. So between this 5.37 this point and 5.38 this point, this has to be again extended into 10 more equal parts. Let me do a line at there. If we go on increasing this number of lines like this, let me take it as a 5.37 and this point is 5.38. So if again I will divide the same line into 10 equal parts, for example it is 5.371, 5.372, 5.373, 5.374, 5.375, 5.376, 5.377, 5.378, 5.379 and 5.38. It is 5.38. Now look at here. This number I have selected, it is 5.371. Similarly, it is 5.372, 373, 374, 375, 376, 377. Now this point represents 5.377. And next point is 5.378. Now you can see our number 5.3775. This next number 5.3775 lies within 5.377 and 5.378. So if I go on increasing this line again into 10 parts, I will find how much decimal places I have to extend. Up to that place I can show through this successive magnification method. Okay, so the successive magnification method of this presentation of irrational numbers on the number line will help us to find up to certain decimal places. We cannot go beyond any place. We can go, but it will be number time taking process. But this is a concept that we can extend this number line up to any extent to express the step of numbers. If you go on adding the more number lines, more magnifications so we can extend the line points and we can show through this. Okay, so this is called successive magnification of the number line to be presented irrational numbers. Okay, now this is the presentation of irrational numbers on the number line we have discussed. But if someone will ask, sir, if it will be a decimal number, suppose it will be 3.4 and its under root is there. So such type of numbers are also irrational numbers. So how to represent such numbers on the number line? To present such type of numbers on the number line, we cannot use this method what we have used in for root 2 and root 3. To use the same process to represent the root 3.4 on the number line, we will use another method. Okay, let us discuss that method. Suppose I can take this 3.4 under root is suppose under root of x. So now x represents 3.4. I can take 3.4, I can take 5.2, I can take any decimal number at the place of x. So in that case, x represents this number, 3.4. And its 3.4 under root is now root x. So I want to represent this root x on the number line. So what are the steps to be presented root x on the number line? Okay, let me go for that. So let us select a line, number line first. Let us select a number line first. I have selected a number line at here. Then through this number line, let me find a point here. Let me take this point as minus x. On the number line, this point is minus x. Minus x means if this point you relate at it is 3.4, so I have taken it as minus 3.4. Okay, and from this minus 3.4, I will find the length of 3.4 unit from my ruler. I will find this length of 3.4 from my ruler. 3.4 from my ruler, then I will cut a point at here. Now, if this point I will represent 0, if this point I will keep as 0, so from 0, if backwards you will come, this point represents minus 3.4, or you can say it is, let me take it as minus 3.4, or you can say it is minus x. Okay, now this point is 0. So from 0, let us take 1 unit towards the right. Again, let me take it as 1 unit towards the right. I have taken 1 unit towards the right. Now, this is 1 unit. This is minus 3.4, this is 0, and this point is 1. So the distance from this 1, let me take this point, name is O, this point is O, this point is A. This point is this point is, I will take, let me take it as P, this is O, this is A. Now P to A distance is how much? Now this distance is 3.4, this point is 1, so 1 plus 3.4, this total distance become now 4.4. This total distance become now 4.4. Now what I will do next? I will divide this PA length into 2 equal halves to find this length PA midpoint. In order to find the midpoint of this length PA, I have to bisect it through the perpendicular bisector. Let me draw, take more than half. Okay, so after cutting this, I will find this midpoint. This perpendicular bisector I have drawn only to find the midpoint, no use of that. Okay. So now this is the midpoint of this line A to P. Let me take this point Q. Now Q is the midpoint of A to P. So now taking this Q as center and QA as the radius, if I'll draw a semicircle, I can draw a semicircle. So let me draw a semicircle. Okay, so this is the semicircle I have constructed, taking this Q as center and this QA as the radius. Now, with the semicircle I have constructed, after constructed the semicircle, I will go to the point O where I have taken 0. So from 0, now I will select another perpendicular to be done. So let me draw another perpendicular. So to construct a perpendicular at here, let me bisect this 180 degree. Then let me join this from O to this perpendicular, let me join and I will produce. So the point where it cuts this semicircle, let me name this point as R. Now OR is the distance which represents root x. Now how to bring this OR to the number line? To bring this OR to the number line, again I have to select this point O as center, OR as radius, then this distance I can bring like this to the number line C. This distance I can bring into the number line in this method. So now here the point where it cuts, let me take it as R dash. Now OR and OR dash both are equal because I have selected OR center. Now R dash represents under root of 3.4 on this number line. Now this is a number line where this is 0, this is 1, this is minus 3.4. This point R dash is under root of 3.4. Okay, in this way we can also represent any decimal number into the this irrational form of any decimal number into this number line. Okay, so this is the way we have to present this irrational numbers on the number line. Okay, so what we learned today, we learned that how to represent the irrational numbers on the number line. We have learned about this presenting root 2, root 3 on the number line. How we have taken? By using the Pythagoras theorem, we have taken this root 2 and root 3 on the number line. Then we learned about the successive magnification method to represent the non-terminating, non-recurring decimal numbers to presented in the number line. Then any other method, we have used this method to present irrational number of decimal numbers on the number line. So these are the things we learned today to represent irrational numbers on the number line. Okay, so in the next class, we'll discuss about the operations of the rational numbers. Okay, so let us skip this class. Thank you.